Next off the concept is sign of slope or gradient of the graphs. This is probably the most important topic which is very important for basics. Earlier we had discussed what does gradient actually mean. Gradient is nothing but the tan of the angle which the tangent makes with the x-axis. And where is this tangent coming from? If we have to find the gradient at the point A, so we need to draw the tangent at that particular point, and then we figure out the angle which the tangent makes with the x-axis, and then we take the tan of that. That is gradient. Now, the value of tan theta is 0 if theta is either 0 or 180, and tan theta is positive if theta is acute. By acute, we mean the theta should be less than 90 degrees. On the other hand, the value of tan is negative if theta is obtuse, which means theta needs to be greater than 90 and less than 180. Now, let us express all of this in a graphical format. So, observe the axis here. Horizontal axis is the angle theta, and on the y-axis, we have tan theta. As discussed earlier, if theta is acute, which means theta lying between 0 to 90, the value of tan theta is positive. Hence, if the angle lies in the first quadrant, the value of tan theta is positive. On the other hand, tan theta will be negative if theta is obtuse, which means if the angle lies in the second quadrant, somewhere over here, then the value of tan theta will be negative. Now, let us use all these concepts to figure out the sign of the slope or the gradient. So, here we go. Let's say on the axis, I show you a graph like this. So, basically, these are just straight lines which are parallel to the x-axis. Now, since they are parallel to the x-axis, which means the angle theta is 0, hence tan theta is 0. So remember the concept, gradient of a horizontal line is always 0. On the other hand, let us consider vertical lines, the lines which are parallel to the y-axis. In this case, the angle which these lines are making with the x-axis is 90 degrees. And remember, tan 90 was infinite or not defined. Hence, the gradient of vertical lines is always infinite. Next off, consider this graph. So this is a straight line which is passing through the origin. But if you observe the angle theta, the angle which the line is making with the x-axis, this angle theta is acute, and we just discussed if theta is acute, the value of tan will be positive. Just remember this concept. If the line looks like this, then the gradient is a positive value. On the other hand, let's take the same straight line, but it is drawn like this, which means now if you observe the angle which this line is making with the x-axis, hence this is the angle theta which we are after. This angle theta is greater than 90, which is obtuse. And when theta is obtuse, the value of tan is negative. Hence, remember, whenever the line looks like this, the gradient will always be a negative constant. And why the gradient is constant in both these cases? Because the graphs are straight lines. And whenever graphs are straight lines, gradient will always be a constant. But the catch here is it could be either positive or negative depending on how the line is drawn. So all of this was straight line graph analysis. But what if we don't have a straight line? Let's say the graph is a curve like we discussed earlier. Now, in this case, let me label various points. So P is on the extreme left, R on the extreme right, and A and Q are the middle points. Earlier, we had discussed that as the value of theta increases from 0 to pi by 2, the value of tan increases, tan theta increases. Now, if you consider all these points, P, Q, A, and R. So as we move from P to Q to A to R, what do you think is happening to theta? The value of theta is actually increasing. At P, the angle theta was 0. At R, it is 90. And also remember, at all these points, the angle theta is acute, less than 90 degrees. Hence, now we can say as we are going from P to Q to A to R, the value of theta is acute. And whenever the angle is acute, the tan value is positive. And next, as we are making this transition going from P to R, the value of theta increases, which means the value of tan theta increases. And now we can summarize all of this in one statement by saying that this graph has an increasing positive gradient. So just remember the basic concept. Whenever the graph looks like this, the shape is important, then it will have increasing positive gradient. Increasing because the value of theta is increasing. And why is it positive? Because the angle is acute. On the other hand, let me show you a different graph which looks similar but slightly different. So here we go. So this graph is also U-shaped, but unlike the previous case, it is sloping downwards. Here also, if we label a particular point A where we have to figure out the gradient, remember the steps. Step 1 is to draw the tangent at that point, and then we will find the angle theta, which this red tangent is making with the x-axis. And step 3 is to find the value of tan theta. So gradient of the graph at the point A is tan theta. And like in the previous case, let us analyze this graph by taking various points P, Q, A, and R. We had discussed earlier that as the value of theta increases from pi by 2 to pi, even then the value of tan theta increases, although the tan theta will be negative. So now if we go from the point P to Q to A to R, the value of theta is actually obtuse. And you can see here also this particular angle is much greater than 90 degrees. So all of these angles at PQAR will be obtuse. At R, if I draw a tangent, let's say that tangent is parallel to the x-axis. In that case, the angle will be 180 degrees. But incidentally, the angle 0 degrees and 180 degrees are actually the same. Hence, tan 0 and tan 180 both are equal and equal to 0. Now, since the angle is obtuse, so the value of tan theta will be negative, which means the gradient at all these points will be negative. Next, the value of theta is increasing from pi by 2 to pi. At P, the angle is pi by 2, and at R, the angle is pi. So, whenever the angle theta increases from pi by 2 to pi, tan theta again increases. Now, if we summarize all this information, we can say that this graph has a increasing negative gradient. Why is it increasing? Because the value of theta is increasing. And why is the gradient negative? Because theta is obtuse. Now, let us summarize what we have discussed so far. So, if the graph looks like this, so a sloping up graph, in the exam scenario, all you need to remember is this graph has an increasing positive gradient. In the exam, please do not waste time in figuring out is it increasing, is it positive, or is it negative. Just remember the shortcut. If the graph looks like this, then the gradient is increasing and positive. But on the other hand, if the graph looks like this, then the gradient is increasing and negative. Now, these two cases we had discussed. Now, if the graph looks like this, it is going up, but it is a downwards U. So you can do the same analysis, but remember the result. Whenever the graph looks like this, then the gradient is decreasing and positive. On the other hand, if the graph looks like this, then the gradient will be decreasing and negative. Now, all these four graphs are going to be extensively used in the first chapter of kinematics, where we have to solve graph-based questions. So if you remember these shortcuts, then you can solve all those questions very quickly. But what I've observed is in the exam, students tend to forget which graph corresponds to which kind of gradient. So to solve that problem, now let us discuss. There is a shortcut to remember the sign of the slope or the gradient. If you analyze all these four graphs, either the gradient is increasing or decreasing. And the shortcut is if the gradient is increasing, then the graph is always an upwards parabola. So case 1, you can see this graph is a part of a bigger upward parabola, hence the gradient is increasing. This is also a part of a bigger U, which is an upward parabola. That is why the gradient is increasing. But if the gradient is decreasing, then the graph will be a downward parabola. So as you can see in case 3 and case 4, both of these are parts of downward facing parabola. Hence the gradient is decreasing in these two cases. Next, if the gradient is positive, how do we figure that out? What is the shortcut to remember that? So the shortcut is y should increase as the value of x is increasing and vice versa, which means y should decrease as x is decreasing. Let us analyze this. So over here, this is positive gradient. So in the graph, you can see as the value of x increases, the value of y keeps on increasing. That's why the gradient is positive. And in case 3, you can also see that as the value of x is increasing, value of y is also increasing. That is why positive gradient. On the other hand, gradient will be negative when the reverse happens. So y should decrease as x increases and vice versa. So in case 2, we can observe that as the value of x increases, the value of y is decreasing. Hence, the gradient is negative. Similarly, in case 4, we observe that as the value of x is increasing, the value of y is decreasing. Hence, the gradient is negative. And these are the shortcuts which you should know to remember the shapes along with the sign of the gradient. And as I informed earlier, this is going to be extensively used in the chapter of kinematics where we solve graph-based questions.